Hello everyone and welcome to this course on RF microelectronics. My name is Ahtasham and I'm a PhD student at IIT Kanpur, working in the field of nanoelectronics. Uh, about this course, let me talk about the prerequisites for this course. Uh, any basic course on circuits and signals and systems should work. If you have a basic understanding of how circuits work or some basic principles of signals and systems, you should be good to go. And for that, I would suggest the analog circuit design by Behzad Razavi. Or there's also devices on there's also books on device physics which you can go through, because a part of this course will focus on devices. So there are books by Cividis or Professor Datta, and there's also a book by Piret, which is a very good book if you want to understand devices. If you want to understand devices, from a physics point of view. So a very good book by Piret. And there's also for signals and systems, you can always look at Oppenheim. It's a very standard textbook for engineering courses. You can look. There's the book by Oppenheim is goes very deep into signals and systems, but you don't know, you don't need to understand the entire subject. Just a basic understanding of what signals and systems are should be sufficient for this course. Now, on the topic of what you learn in this course is what I've tried to do is that I've tried to divide the entire videos, the entire course into small 10-minute or 15-minute videos so that it's easy to understand. And we'll focus most of our time. Most of our time will be spent on understanding the nomenclature and the basic principles, the fundamentals of RF microelectronics. We'll try to understand S parameters and how to work with Smith charts, and then we'll move on to matching, impedance matching, and then eventually the target of this course is to understand power amplifier and low noise amplifier design. Very basic designs, but the goal is to get you acquainted to the design techniques, basic design techniques, and then act as a launchpad for you to explore the area of power amplifier and low noise amplifier design on your own. A big part of this course will also focus on the various devices, and then we'll also discuss measurements, RF measurements, both on wafer as well as for packaged devices, and we'll see how those measurements are done and what are the different equipments we need to do those measurements. Now, this course it is definitely challenging because these topics, they come from various fields of the electrical engineering discipline, and in order to understand RF microelectronics, you have to be very good at connecting the dots. So you'll look at different aspects from different fields, and you have to be able to understand each one of them, and then you have to be able to correlate between those aspects. So it is definitely challenging, and what is challenging is also fun, right? So for some people, it can be, the challenge itself is fun. So it can be a good challenge, and then at the same time it can be a very engaging activity to sort of put yourself out there to this task of understanding RF microelectronics, and that in itself can be very interesting. The other thing why you should learn about this field is that it is very relevant to what's going on right now. So we keep on hearing these buzzwords, 5G and 6G, and all the future technologies of communications, and they are really the basis of the society today. Everything, the entire internet economy depends on the underlying communication infrastructure, right? So all of what's possible today because of you know the content creation and all the influencers. You see YouTube or TikTok, or all the other social media giants, um, which are new sources of income. And the underlying principle, the underlying the basis of all that is that we have high speed networks like 4G, which have made it possible. It was not possible previously because of 2G, or you could not have the scale which we have today on 2G networks. It has all been made possible because of 4G networks and because of fiber optic networks. And going forward, this is going to be the key technology. Uh, you know, be it 5G, which is currently being rolled out in many countries, and even the future 6G technologies, which are going to decide, the shape of the world tomorrow, and the way in which the world is moving. It's all going to be decided by these technologies. And besides that, RF microelectronics in itself is a very niche skill. So you'll not find many people working in RF microelectronics. And what that does is that if you understand RF microelectronics properly, then you are a person who is needed at many places. And for that, you'll be offered a lot of money. So normally RF microelectronics people, they're paid very good salaries. So if you are from this field and if you understand RF microelectronics, if you're good at amplifier design, if you're good at LNA design, if you're good at measurements, RF measurements, it is a very lucrative and a very interesting, I would like to add, a very interesting job profile, which you can pursue, a very good prospective, which you can look into, and it offers a lot of money. So that's there. Now, let me just go through the course content in a very summarized manner. Let me talk about what we'll discuss throughout this course. We'll start with and all of this content will be divided into small chunks. I'll not talk about you know these topics for an hour or 2 hours to make it boring. We'll make small videos of maybe 10 minutes on each topic. I'll try to break down the topics into even smaller subtopics so that it's easier to absorb, and it's easier to refer to them whenever you need to. Because if I make a long video and then you don't know where a certain topic is being talked about, so it's better that I make small videos which can always be referred back to if the need arises. So the course content would be, we'll start with maybe in this and the next video. I'll talk about a brief overview of what RF and wireless is all about. What are the different aspects? What are the different trade-offs that need to be taken care of? Then from there, I will shift to the concepts in RF design. So the units in the jargon that's used by RF microelectronics people, topics like gain compression, like harmonic distortion, modulation, intermodulation, noise sensitivity, dynamic range. We'll talk about all of these, what they mean, and what is their implication on circuit design. Then we'll also talk about some topics which have relevance from an application point of view, like impedance transformations or scattering parameters, or then there'll be other topics like measurements. We'll also talk about we'll talk about Smith charts, which are a very important tool. So we'll talk about Smith charts, and we'll also in measurements we'll talk about how we perform these RF measurements. And in these measurements, a very important device is the network analyzer. So we'll talk about the basic principle of a network analyzer. And we'll also talk about Smith charts. We'll talk about how to design matching networks. We'll see why we need matching networks. So these are all the topics, an overview of all the topics we'll be discussing throughout this course. Mm, Then we'll also talk about devices. So, what are the different passive and active devices which are used when performing circuit design? And we'll also spend some time on the modeling of these devices. Since I come from a modeling background, uh, this is something I'm very excited to talk about. We'll see how these devices are modeled and how those models are used in circuit design tools, to get a performance which is as close to the actual designs, to the fabricated designs as possible. And we'll also talk about nonlinear circuit simulation techniques, and we'll see what these mean. What is a nonlinear circuit simulation, and what are nonlinear effects when we talk about RF networks. Then we'll spend a good amount of time on these topics, which is the amplifier design. We'll see how basic amplifiers. We'll talk about simple amplifiers, and we'll see how what is the conventional methodology, or what are the steps you have to follow in order to design a very simple amplifier. And then we'll talk about RF measurements, and then we'll talk about transceiver design. But this would be brief. So we'll talk about how we combine these amplifiers as well as things like RF switches. Right, we will talk about how we combine all of this to form a complete transceiver. And a transceiver is a device which has both a receiver section and a transmitter section. So you have a power amplifier as well as a low noise amplifier, and you have some RF switches which help you switch between the two. So that's what a transceiver is. And transceiver modules, these modules can be found in almost all communication equipment, including your smartphones. Now, I'll be following certain books, and I'll be following them with varying details. But the key books I will be following throughout this course would be RF Microelectronics by Behzad Razavi and Microwave Engineering by David M. Pozar. And besides these two books, you can also look at the Practical RF Circuit Design for Modern Wireless Systems. And then there's this Design of CMOS Radio Frequency Integrated Circuits. So these two books, there will be some sections. There'll be some sections which will be based on these two books. Then if you want to go into details, if you want to understand some things better, there are also some books by Ein and Wood. There's this book by Civides on the modeling of MOS transistors, if you want to look at that in detail. Then for this course, I have also some images have been I would like to mention have been taken from some NPTEL lectures. I found those images interesting. I will refer to them whenever we get to those images. I'll let you know which of them are from certain NPTEL courses. And I found them very interesting, so that's also something I would like to share. And so that is all for reference material, and that is it for this lecture. So in the next lecture, we'll meet and we'll talk about an overview of what RF microelectronics means. So see you in the next lecture. Bye.